Hey guys, and welcome back to another Animation 4 tutorial. In today's video, I'm going to be showing you how to set up an animation blueprint in Blendspace so that we can go from idle, walk, run, and jump. So let me show you what we're going to be creating today. So if I hit play, we can see this is what we're going to have. So we've got our idle pose here, so our idle animation. When we start walking, we get this, and we can also start running as well. And if we jump while we're moving, we're going to get an animation like that. And if we stand still and jump, we're going to get a jump animation like this. And you can see it smoothly and easily blends between all these different animations like so. So we set up an animation blueprint for our different characters, for our different player, so it isn't for the UE Field mannequin. So this is what we're going to be creating today. So let me delete this code and show you how I've done this. And so the first thing we're going to want to do is import our animations in character. So for me, I'm going to be using the animations in character from Mixamo. So let me get this up and show you. So you can see here, this is where we have the Mixamo. So let me just get the SWAT character up on here. I can just remove that there. So in the characters, you search for SWAT and get the character here. And now there's a lot of different animations that we can have, or characters, sorry. So you can see we have a very wide variety. And if we go on animations, we also have a big variety of different animations here. It is all completely free for you to be able to use in your games. However, I assume you've probably already got your animations and your character in there as well. But one thing I want to make sure you do is if you have, for example, a walk animation, so let's get this one, you see that it will look like this. We want to make sure that we tick in place. Now this is important to do for the next steps to work in actually creating an animation blueprint. If you don't have in place ticked, or if you can't tick it, we're going to need to enable root motion in Unreal Engine itself. Now if you have any issues with this, or if you'd like more explanation, let me know in the comments down below and I can get to you with that. But once we've imported them all, so you can see here I have our main mesh folder with the skeletal mesh, physics asset, and skeleton, and the materials here as well. And then I also have my animations folder here. And what I'll do is I'll delete one of these animations, so I'll delete jumping down, and I'll re-import it just to show you what it's going to look like when you import, just in case you haven't done that yet. So we can just drag and drop our animation in here like so, and you're going to want to make sure that the skeleton is your SWAT skeleton, or the skeleton you have for your new character, which again for me is SWAT skeleton. And leave everything else the same, so animation length, exported time, and import all. Again, I'm not going over this part too much. I do have a video, however, going over creating a character and importing it from Mixamo into Unreal, so I'll leave that linked on screen now. However, once you've got all of these, we want to set up our animation blueprint. So I'm going to do this in the animations folder I have here. So I'm going to right click, go to animation, and I'm going to get an animation blueprint. We want to make sure this is on the skeleton for our character, which again for me is the SWAT skeleton, and we're just going to hit OK. And I'll name this SWAT Anim BP for animation blueprint, and we'll open that up straight away. You can see in the top left here we have our preview, so at the moment we haven't got any animations, so it's just going to be a T-pose like this. And in the anim graph we have output pose. What we're going to have is different animations in here going into the output pose. However, we'll get to that in a second. One thing we want to set up first is the event graph. So let's go to the event graph in the top left here and set this part up first. However, one step before this is we're also going to finish setting up the character blueprint. So we wanted to make sure we made the animation blueprint first as well. However, let's set the character blueprint up as well. So we minimize this, go to our character blueprint, which for me is content, third person BP, blueprints, third person character. What I'm going to do is go to the viewport, select the mesh. I'm going to change the animation asset, so use animation blueprint, anim class to be our new animation blueprint we just made, which mine is SWAT anim BP. And I'm also going to change the skeletal mesh to be my SWAT skeletal mesh there. And you can see we compile, it's going to be using the anim BP, which again is just T-pose for me. And then while I'm in here, I will also set up some sprinting code. So I'm going to go to the event graph here. I'm just going to simply right click, get a left shift keyboard event. Now I do have a more in-depth video on creating a sprinting and stamina system, which again I'll leave a link to on screen now. I'm going to drag and drop character movement out of this, set max walk speed, and off of pressed, I'm going to set this to be 600, and then released, I'm going to set it to be 300, like so. And then I'm also going to select the character movement and change the default max walk speed to be 300, as you can see here. By default, it's 600, but I want it to be 300. So I'm going to close, compile, and save that. Now we can close the character blueprint, as that is all we need to do in there. So back in the animation blueprint event graph, what I'm going to do is move the try get pawn owner up a bit, so where we have this event here. I'm going to right click and get event blueprint begin play. Out of try get pawn owner, we're going to cast to our character, which for me is just the third person character, but for you to be third, first, or whatever you've named it. And then as third person character, we're going to right click, promote to variable, and name this character reference, like so. We're doing this here because it's more efficient to only cast once at the beginning rather than constantly. And now you can just come out of Try Get Porn Owner, you don't need to cast your character. However, if you have anything specific in your character blueprint, then you will need to cast to it, like we are here. So now under here, off of Event Blueprint Update Animation, we're going to come out of that and get an is valid with the question mark next to it there, with the input object as our character reference there. So now it's only going to fire off this code afterwards if this has already been set, because it won't be set immediately, only after a short delay, and it's a very short delay. So it is not valid, we don't want to do anything. Is valid, we want to start setting the variables we're going to need. So what we want to do first is set the speed. So we're going to come out the character reference and get velocity, which again you can just do off of Try Get Porn Owner here, but I'm going to do it specifically for this character. Out of the velocity, we're going to simply get a vector length, and this is just going to get the speed in a float value. And then we can right click the return value, promote to variable, and name it speed. So now we have the player speed, or the character speed, in a float value, like so. And now we also want to calculate the direction. Now I'm not actually going to use the direction in this, however it's always good to set it up just in case you want to use it later on. So that's very simple. What I'm going to do is right click and get a calculate direction node. The return value, I'm going to right click, promote to variable, naming it direction. And this again is a float value. The target will leave a self, as we want it to be this character blueprint. The velocity can go into our get velocity there. The base rotation will come out with the character reference and get actor rotation. And this will automatically calculate the direction for us. And so now we have our speed and direction variables set up here. Now there's one final one which I want to set up, and that's a boolean called isJumping. So what we can do is again come out of our character reference, so I'll get another one there. Out of this, we're going to get the character movement, should be at the bottom I believe, get character movement there. And out of this, we're going to get is falling, or just is falling, sorry. So it is falling there. And this is obviously going to be true or false, depending on if the character is falling or not. Right click the return value, promote to variable. I'm going to name this one is jumping. You can name this is falling if you'd prefer, but I think is jumping makes more sense for me. So that's what we're going to do there, like so. So now we have our speed, direction, and is jumping variables all set up here for us to be able to use, and we're going to use those to transition between different animations. So this is what we should have so far with this all set up like so. So if we compile, save, we can go back to the anim graph. Now to have all these animations together and blend in between each other, what we want to do is put them all in a state machine. So we're going to right click and add state machine, or add new state machine like that. I'm just going to select it and rename it to be locomotion SM for state machine. Now you can name this absolutely whatever you like, doesn't matter too much, but that's what I'm going to have. And what I'm also going to do out of this is get a slot default slot. Now this is not necessary at all. What this allows us to do is simply just use animation montages later on. So I'm not going to go over that in today's video. However, it's always good to just have it if you think you're going to use anim montages later on in your project. So again, you don't need that if you don't want to, but I'm going to have it. So if we compile, we can see that we're using this state machine here. However, we get a warning, and that's because we haven't got anything in there yet. But you can see that these lines coming off here because it's using it. So we can double click the state machine to open it up, and we can start putting everything in here. So what I'm going to do is come up with the entry. I'm going to add a state. I'm going to name this one to be idle. Now we can have our idle, walk and run all in one state. However, I'm having it as idle and then walk and run just to make it a little bit easier on you to understand. Then out of the idle state, I'm going to drag out and add another state, naming this one walk run. So we're going to have our walk and run both in one state. However, again, the idle will be separate. And out of walk run, we're going to drag back into idle. So we have these arrows connecting them like so, which means we can go from idle to walk run and walk run to idle. Out of idle again, we're going to add another state. I'm going to name this one jump start. Out of jump start, we're not going into idle. We're instead going to go into another state named jump loop. Jump loop won't go into jump start again. That will go into another state named jump end. And that one will then go back into our idle like so. So we've got this kind of triangle loop here, meaning that if we jump, it's not just going to play one animation, it will play 3 separate ones so that we can get a much nicer looking jump animation, so it smooths out, especially if we jump a long distance. It's not just going to play the same animation or just play it once and then T-pose, it's going to have a nice loop that we would have here. So let's just neaten this up a little bit like so, and I think that looks good. Out of the walk run, we're going to go into another state. I'm going to name this walking jump, or just jump if you prefer. But again, I want this one to be a jump if we're moving. This one you also don't need to set up at all. You'll find most of the time you probably wouldn't have this. However, I'm going to add it in just to show you how to do it in here as well. So again, just so you learn a bit more, and also you might prefer how it looks as well, which again you saw at the start of the video. Out of the walking jump, I'm going to go back into our walk run state there. And I'm also going to go from walking jump into jump loop, so that if we then are walking and we jump off a building, let's say, it will then also loop and play the end as well, meaning it will look a lot nicer. I'll just drag that up to keep it a bit more organized like that. So this is the basic look of our state machine so far. So what we need to do next is add in the animations. So I'm going to go through them all one by one. So let's do the idle first. You can double click the state to open it up, and you can see on the bottom right here we have all of our different animations. So I can just drag and drop the idle in, put that into the output animation pose, hit compile, and you can see in the top left we have our idle animation playing there. So that works perfectly. So we go back to our state machine, and I'll just go into jump start, and this one is named jumping up for me. So jumping up like so, hit compile, and again if you want to use the same animations, this is what they're all named on Mixamo. I haven't renamed them at all. You can just search for these animations on Mixamo, and this is what they're called. Go back to the state machine, go into jump loop. This one is called falling idle, like so there. Compile, go back to the state machine, jump end is jumping down, so we're essentially landing from our jump. Go back to the state machine, and then the walking jump is jump forward for me. We go back to the state machine, you'll know we've missed one out. That's the walk run. What we're going to do is open this up, but this isn't going to be just an animation, because let's say we have our walk and our run animations. Let's plug in the walk and let's plug in the run. However, we can't do that. We can't have two different animations in here. Now there are different ways of doing this, however a blend space is the most efficient way, and it looks the best as well. So we'll delete these animations and let's make a blend space. So let's compile, save, and minimize this. Let's go back to our animations folder that we created, so SWOT animations, and let's right click, go to animation, and I'm going to create a blend space 1D. The difference between a blend space and a blend space 1D is a blend space will include direction. So if you want different animations for going forwards, backwards, left, or right, you'd want a blend space. And now I do have a video on creating directional movement like that as well. So if you want, I'll leave a link to that video on the screen now as well, so you can watch that if you like. But in this example, I'm making a blend space 1D. Again, making sure it's the SWOT or the correct skeleton for you. I'm going to name this one walk run BS for blend space like so, and open it up straight away. You see this is quite a simple interface. So we have our graph down here and the axes up here. So the horizontal axes, which is the only one we have, I'm going to name speed, the minimum value as 300 and the maximum as 600. So let me put that back to 300. And now the reason I've chosen those values is because that's my minimum and maximum walk speed. So you might have different speeds. So if you want the idle in here as well, you'd put it as 0. Or if your minimum speed is 100, put it as 100. If your maximum speed, so my sprinting speed, if for you that's 1200, put it as 1200. You just customize these values to get them perfect for you. Number of grid divisions I'll leave as 4. I technically only really need 2 or 1, but I'm going to leave as 4. The interpolation time is basically how smoothly it transitions between them. However, I prefer using the target weight interpolation rate per second, I believe it is. Interpolation speed per second down here under sample interpolation. I prefer putting that at about 5. Any value between 5 and 10 is nice, and again, that just smooths the transition between the animations. We can save that. And now let's put our animations on here. So if we go to the asset browser in the bottom right, drag on our walking, so swagger walk for me, put that all the way on the left. As you can see, the speed's 300, that's when I want to walk. All the way on the right, the speed's 600, that's when I want to run. Now if we hold down left shift and move our mouse on here, we can preview the animations. So if we're here, we're going to be walking. If we're here, we're going to be running. And again, you can put as many different animations on here as you like, all dependent on the player's current speed. And again, with the other blend space, you can do direction as well, which again I have different videos on. So now if we save, we can close this, as that is all we need to do, and that is very simple. So what you see here, this is updated to have that blend space in here as well. So we can drag and drop walk, run, blend space in here, plugging that into the result. And you can see it's asking us for the speed, and that's because that's what we named that axis. And we've already set up the speed earlier, So we just drag and drop, get speed, plugging that in there. And now what this does is, depending on the player's speed, it's going to transition between our walking and running animations. So now if we compile, this is all the animations set up. However, you can see we're still getting these issues here because we haven't set up the transition. So we've set up the animations, however it's only going to ever play idle, it won't leave that. So let's set up transitioning between them now. So what I'm going to do first is idle to walk run. So we have this line here, just above it we have these kind of two lines here. We're going to double click that to open it up. To transition to walk run, we just want to see if we're moving. So we're going to get the speed, so drag and drop, get speed, and we're just going to come out this and get a float is greater than or equal to a float. I'm going to set this value to be 5. You set this to be whatever you want, but I know that if the player is moving faster than 5, we're going to be moving. We're going to be walking, so we want to play those animations. So we go back to the state machine, go to walk run to idle, we're going to get the speed, and this time I'm going to get a less than or equal to. So float is less than or equal to a float, and I'm going to set this to 4. So if we're moving at a speed of less than or equal to 4, we don't want to be moving anymore. You can set that even lower if you want, so let's say 1. We compile and save that. Go back to the state machine, and now we can go between idle, walk, run. However, the jumping won't work yet. So let's do our nice jump loop that we have here first. So we'll go from idle to jump start, so double click that. And for this, we want to simply get our is jumping variable. So plug that in there, so the boolean will go into the result there. So if this is true, we can enter it. If it's false, we can't. Go back to the state machine and jump start to jump loop. This one is slightly different. What we want to do here is we want to see if the other animation is just finished playing. So if the jump start, so we're jumping up, if that's finished playing, then we can go to this one. So we're going to get time remaining with our ratio to jumping up there. Out of the return value, I'm going to get a less than float, so a float is less than a float, plugging that into the result there. And now the value I'm going to have for here is 0.2. Now this will differ depending on your animations, so you might need to just mess about with these to get them looking good for you, because otherwise it might glitch out, it might look a bit bad. So you can just get in, change these values, trial and error like so, and the values which I found good for this animation was 0.2. Go back to the state machine, and then we'll go from jump loop to jump end. This one is going to be is jumping. Out of that, we can get a not boolean, plugging that into the result there. So if this is not true, then we can enter it. So when we stop falling, so we stop jumping. Go back to the state machine, jump end to idle is again going to be the time remaining. So we're going to get time remaining ratio jumping down. This one is again less than a float, and the values which I found good for this animation were 0.6. That's the one where I don't get any glitching or it looking bad. So again, mess about with the values to get them looking perfect for you. We'll go back to the state machine. The only ones we have left now is our walking jump. So we're going to go from walk run to walk and jump first, and this is again it's jumping. Plug that in there. We'll go back to the state machine. Now the reason it will go to that one and not this jump is because we're walking, so it has to go from this state instead of this state. That's how we can have the transitional line the same. And then walking jump to walk run is again going to be is jumping not boolean. So if we're not jumping, like so. Go back to the state machine, and the final one to set up is walking jump to jump loop. This again is time remaining ratio jump forward. The value which I found good for this one was obviously less than, and the value was 0.3. We can plug that in, compile, and now we have no errors as we set this all up completely well. So we can go between all of these values, and with the walking jump, it's either going to go back to our walk run if we stop jumping, or jump loop if we're still jumping and the animation is finished playing. So again, we go from idle to walk run, and if we're idle, we can jump, and we'll have a nice loop. And if we're moving, we can jump forward and also go into loop if necessary. So if we compile, save, we've already done everything else we need, so we can minimize and hit play to test this. So you can see we have our nice character here, playing the idle animation. If we start walking forwards, we're going to walk. If we start running, we're going to have the run animation. And if we're moving and we jump, we get that jump animation, and you saw it went into the loop when it was necessary to. If we're not moving and we jump, we get that nice jump animation. Now you saw there, it kind of did that glitch there. So that's why we mess about with the values, to get it looking a lot better for us, so we don't get that animation looking like that. So let's do that now. That's a good example, so we'll mess about with them. So it's going from jump start to jump loop. It's playing again, so we're just going to go in here and change this value. So if we maybe change it to 0.4, increase it like that, we can test this again and see if there's any better. So we jump, we still get the same thing. How about let's put it to 0.6 to match the other one. You see, that's getting better. Put it up to 0.8. So again, you just got to mess about with it to get it perfect for you. Not sure why it's different this time, as I'm using the values I found earlier when messing about with it. Let's try, and you can see that it looks a lot better now. So we're not getting the glitch. So again, if you get anything like that, just increase the values until it looks a lot better for you. And so this works perfectly. Again, very customizable to do, very easy to add on to, and I do have a lot of videos where I am adding on to this as well. But I think that'll be it for this video, as we've done everything we want to do. We've set up this animation blueprint and animation blend space in which we can walk, run, jump with a jump loop, and also jump while moving forwards. And this all looks great. And again, if you have any issues or you'd like any help with setting anything else up, just let me know in the comments down below, and I'll be happy to help you out. So thanks so much for watching. I hope you enjoyed and I hope you found it helpful. And if you did, make sure to like and subscribe down below. So thanks so much for watching, and I'll see you in the next one.